Hello, dear friends. How are you? I hope you all are safe. Now, welcome you all in our today's session. Okay. So, as you know, beta, we are discussing what? Yes, we are discussing numericals on our limiting reactant. Okay, few numericals we discuss. Now, you concentrate on this numerical. That is here one numerical beta. Question. Mg plus here one question beta. Mg plus Mg plus half O2 that gives what? Yes, that gives they gave here MgO. Okay, on starting with 48 gram of Mg. Okay, what will be our question? On starting with on starting with 48 gram of 48 gram of Mg and what beta? Yes, 64 gram of O2. 64 gram of O2. Calculate the mass of MgO formed. Then what beta? Then calculate mass of mass of MgO formed. Okay. So this we have to calculate. So pay attention on this question beta carefully. Okay. So I hope you wrote this question. Mg plus half O2 that gives what? MgO. Now here we have to write what? Reaction first. So whatever they give reaction already. So no issues. So we have to rewrite this equation again. So what it is? Yes, Mg plus half O2 that gives what? Yes, MgO. Okay. Now as you know here, how much they give? Yes, beta 48 gram they give. 48 gram of Mg and what? 64 gram of O2. So as you know, 48 gram of Mg means what? Yes, beta एका मॅग्नेशियमचा atomic mass किती 24. मग इथे किती दिलं 48 ग्रॅम म्हणजे हे किती असणार आहे 1 मोल की 2 मोल येस 2 मोल बिकॉज 48 gram. Understood? Now here what? 64 gram of O2 they give. No beta इथे काय होणार 2 to cancel 1 mole of oxygen only. How much? 32. So here how much? 64. So here also their moles how much? 2 mole. I hope you understood on the basis of this gram. म्हणजे ज्या वेळेला आपल्याला ग्रॅम मध्ये जरी दिलं असेल तर त्यावेळेला आपल्याला काय करायचं तसे कन्वर्जन हे मोल मध्ये करायचंय. ठीक आहे. So see here, what is our next work? Yes, we have to decide whether in this reactant, among this reactant, which one is limiting reactant. Okay. So see here, beta. Yes, mole divided by stoichiometric coefficient 1, and here also 1. Yes, here your answer is how much, beta? 2, and here 2 divided by how much? 0.5. Yes, your answer how much? 4. Understood? So as you know, among this, here value is 2 and here value how much? 4. Now among this, which one is limiting reagent and why? Yes, very good. Least value, you are limiting reactant. Okay. So this was consumed earlier in a reaction. Okay. And we call it as a limiting reactant. And whatever this is what? Yes, excess reactant. I hope you understood this thing carefully. Now, question is what, beta? Yes, question is what? How may calculate the mass of MgO form? Okay. So, beta, as you know, here also your 2 mole. Okay. And here also your what? 2 mole. Now, here relation with what? Here Mg. Okay. मग बेटा एका मोल ऑफ Mg मधून किती मिळतात आपल्याला? Understood? So see here we will solve here. 1 mole of Mg मधून आपल्याला 1 mole of Mg मिळते. मग 2 mole of बघा इकडे 1 mole of Mg मधून आपल्याला किती mole of Mg मिळतील? Yes, 1 mole only. ठीक आहे, 1 mole only, or we can mention here yes 1 mole of MgO only form. मग बेटा हे 2 मोल आहे, मग ह्याचं 2 मोल ऑफ mg मधून किती मिळणार? येस ऑब्विसली हाऊ मच? 2 मोल ऑफ mgo. ठीक आहे. So here you will get easily answer. And now here what? And that moles you have to convert into what? Mass. Finally we have to calculate what? Mass. So we can convert moles into mass. Yes, by multiplying factor with whatever mass of MgO. Okay. Then 2 into what? Yes, 24 plus 16. Yes, mg एका mg का मास किती आहे? 12 आहे. ठीक आहे. सॉरी, एका mg का मास किती आहे? 24 प्लस एका ऑप्शन टू किती आहे? 16. So 24 plus 10, 34 plus 6, 40. So as you know, multiply by molar mass. Yes. So how much beta you will get? Yes, mass of MgO form 40 gram. Okay, how much beta? 40, sorry, 2 into 40, that is 80 gram of mass of MgO form after when you starting that with 40 gram of Mg and 64 gram of O2. So beta, like that you have to calculate this our numerical carefully. Okay, I hope you understood this thing clearly. So beta, you can write here whatever our this numerical carefully. Okay, so I hope you wrote this our numerical. नाउ यू अंडरस्टूड. जर का ग्राम मध्ये जरी दिलं असेल तर पहिल्यांदा आपल्याला जसं काय करायचं, कशामध्ये कन्वर्जन करायला लागणार? मोल मध्ये. अंडरस्टूड. सो दिस थिंग यू कीप इन माइंड. ठीक आहे. नाउ वी विल सी बेटा नेक्स्ट न्यूमेरिकल. सो पे अटेंशन ऑन अवर नेक्स्ट न्यूमेरिकल. ठीक है. See beta how we can solve our next numerical. See. 0.5 mole of barium chloride. Okay, so what they give in next numerical? Pay attention beta. Yes. How much they give? 0.5 mole of 0.5 mole of BaCl2. Okay, is mixed with is mixed with 0.2 mole of, yes, 0.2 mole of sodium phosphate, that is Na3PO4. Okay, then calculate. Okay, then calculate the maximum. Calculate the maximum number of moles. Calculate the maximum number of moles of barium phosphate, Ba3PO4 twice. So you must know here what will be the chemical formulas of this. Okay. So I hope you understood this whatever numerical beta. Okay. So see here, 0.5 mole of BaCl2 is mixed with 0.2 mole of Na3PO4. Then calculate the maximum number of moles of barium phosphate. So here what beta, you have to write here reaction. Thereafter you will get what? Reaction, that is a product you will get easily. Okay. So see here, we will write our reaction. Okay. बघा BaCl2 ने आपल्याला काय करायला लागेल? Na3PO4 ची रिएक्शन करायला लागेल. ओके, सो सिंपल. BaCl2 plus what? Yes, Na3PO4. Okay, that gives what? Yes, that gives, you will get Ba3PO4 means what? Suppose if you are considering the reaction, as you know how we will break into its ions. See. Yes, your barium is what? Cationic part, your Cl is anionic part, your sodium is positive, this PO4 phosphate is negative, so you will get what? Yes, very good. Old bond will break and new bond will form. Okay, so like this you will get Ba and PO. So what you will get? Ba3PO4 twice. Means here you will get what? Stable binary compound. Or beta we call it as a stable binary compound. Here you will get. Plus what? Yes, plus what? Obviously NaCl. Okay. See NaCl. So here you can easily balance now here Ba3. So here what we have 3Ba. Understood. So here 3Na, here 6Cl. So yes, 3 as like this. So for that PO4 twice, so here too. Now we can cross check whatever whether our reaction is balanced or not. Okay, so see here 3Ba, 3Ba, 6Cl, 6Cl, 6Na, 6Na, 2PO4, 2PO4. I hope you understood this reaction carefully and you wrote that reaction also. Okay, so pay attention, beta. How we can again we have to do what? We balance. Our balancing is completed. Now we have to concentrate on how much they give mole. Yes, here what obviously they give directly mole. So we can easily what calculate what beta. We can easily decide here which one is among here what limiting reactant and which is what excess reactant. Okay. So pay attention. 0.5 mole of BaCl2. So here how much? 0.5. Okay, divided by what? Stoichiometric coefficient. So 0.5 by 3. Near about you will get answer 0.16 mole. Okay. Now here what they gave is sodium phosphate. How much that? Yes, zero point 0.2. So beta how much? 0.2 by 2 you will get how much? Yes, zero point 0.1. Okay. So on the basis of this you can easily conclude which one over here beta 0.16 but here what 0.1. Yes, सही पहचाना. Here what 0 means this is a limiting reactant which is consumed earlier in a reaction or it is in lesser amount. I hope you understood this thing. ठीक है बेटा limiting reactant. Understood? ठीक है. So here beta now we can easily justify. So obviously whatever further calculation it depends on your limiting reactant. Okay, you then calculate the maximum number of moles of barium phosphate. Okay, barium phosphate form. ठीक है. So say 2 मोल पासून आपल्याला किती मिळतात 1 मोल. Okay, we will do here calculation. 2 मोल of sodium phosphate मधून किती मिळतात आपल्याला 1 मोल of your barium phosphate. ठीक आहे. मग ह्याच्या 1 मोल मधून किती मिळणार. जर का आपण 1 मोलचा याचा विचार केला तर किती मिळणार. येस 1/2. ओके. मग ह्याच्या 0.2 मोल मधून किती मिळणार म्हणजे जे काय आपण कॅल्क्युलेशन करून जी कॅल्क्युलेशन करून नाही जी काय ऍक्च्युअल व्हॅल्यू आहे त्याची 0.2. मग त्याच्या 0.2 मधून किती मिळणार आहे ते इंटू मल्टिप्लाय बाय 0.2. सो ऑब्विसली हाऊ मेनी मोल ऑफ युअर barium phosphate will form. Yes, 0.1 mole of barium that is Ba3PO4 twice is formed. Okay, I hope you understood this thing clearly here. Okay, like that you have to do the relation. Understood? So beta like that you have to write carefully. Okay, understood? So beta without wasting time you write this properly. Okay, we will solve our next example on the basis of what our LR only, that is limiting reactant. Okay, so pay attention. We will start. I hope you wrote completely. So see here beta. We will clean this first. So pay attention. We will solve here one more numerical of our limiting reactant. Okay. See beta. Limiting reactant. We will solve here one more numerical. So see, they gave here one question as like this: 50 kg, 50 kg of into gaseous, okay, and what beta 10 kg of H2 gaseous, okay, are mixed, okay, to produce what? Are mixed to produce ammonia gas, are mixed to produce ammonia gas. Then here, small a, small a what? Okay, small a what? Identify, identify the limiting reactant, identify the limiting reactant in the reaction, in the reaction, and small b calculation is what? Yes, calculate the ammonia gases form. Calculate the ammonia gaseous form. Okay. So it is our numerical. So you have to rewrite this properly, whatever your numerical. Okay. So see here what will happen and how we have to do this calculation. So see here already they given into kg. So we can convert into what? Gram by multiplying factor 10 is to 3. So see here already suppose फक्त आपल्याला पहिल्यांदा काय लिहायला लागेल? Yes, reaction. So here that reaction is important. So we will write here a reaction here. Yes, as you know how we can write the N2 gaseous plus 3H2 gaseous, that gives what? Yes, 2NH3 gaseous. Okay, as like this here reaction. So beta here how much? 50 kg. Okay, मग आपण त्याला ग्राम मध्ये कन्वर्ट करूया. Yes, 50 into 10 raised to 3 gram. And H2 how much? Yes, H2 is your what? 10 into 10 raised to 3 gram. So we have to calculate what? Yeah, you have to identify limiting reactant. Okay. So how we can calculate? See, beta. First we will what? We will do calculation of mole. First we will calculate mole on the basis of this. So how we can calculate? Yes, given mass. As you know, mass of substance in gram divided by what? Atomic mass. Okay. So here N2 चे किती बेटा? Yes, 28. एका नायट्रोजनचं 14 आणि 2 नायट्रोजनचं म्हणजे N2 चे किती? 28. So here H2. Yes, H2 beta how much? एका H2 चे किती असतं? 2 gram. Okay. So how you will get and what you will get here answer as like this. See, yes, near about 1.786. Okay, into 10 raised to 3. हे काय झालं? मोल आन्सर याचं आलं. आणि बेटा याचं किती येईल आन्सर? Yes, 5.0 into 10 raised to 3. 2 5 are 10. Okay, हे काय आलं? मोल. मग आपल्याला इथे अजून स्टेप करायला लागेल. What? We have to identify limiting reaction by dividing its stoichiometric coefficient. So as you know, what will be the stoichiometric coefficient beta? Yes, here 1 and here 3. Okay, so we will do that also. 1.786 into 3 divided by what? 1 is equal to what? Yes, here for this. आता आपल्याला याचे करायचं आहे. Okay, 5.0 into 10 raised to 3 divided by how much? Yes, 3. So see here. Yes, here your answer how much? 1.78 into 10 raised to 3. आणि इथे बेटा तुमचं किती आलं? Yes, 1.66 answer. Okay, how much beta? 1.66. Okay. So like that, you can beta cross check your answer. Okay. Here what beta? 1.786 and another what? Yes, 5 into 10 is to 3 divided by what? 3. Understood? So as like this, you will get your answer. Okay, 1.66 into what beta? Yes, 10 raised to 3. Like this, you will get answer. Okay. So here, now you got what will be your answer here. Okay. So you can identify which one is limiting reagent and which one is what. Yes, very good. Here you are here H2 is what? Limiting reactant. So you can observe this. Okay. You can observe here your calculation as like this. Okay. So this what consume earlier in a reaction. So it is what your limiting reactant least value. Okay. I hope you understood this thing clearly. So again, whatever calculation means calculate the ammonia gas form means here whatever our first calculation is over. Okay, here beta, whatever our first calculation is over. Identify the limiting reactant. Yes, we identify. Yes, H2 is whatever. H2 is limiting reactant. And now on the basis of this, we have to justify. We have to identify how much and calculate the ammonia gas form. Okay. Now see here, or we can say calculate the mass of ammonia. काही मास मध्ये दिले असेल किंवा मोल. ठीक आहे, दोन्ही सुद्धा आपण आन्सर इथे काढू शकतो. आयदर इन मास और आयदर इन मोल्स. मोल्स म्हटल्यावरती तसंच राहणार, मास म्हटल्यावरती काय म्हणणार? येस, मल्टिप्लाय द मोलार मास. ठीक आहे. सो सी हियर हाऊ मच इझी आफ्टर दिस. सो सी हियर बेटा 3 from 3 mole of H2, how much? 3 mole of H2 मधून आपल्याला किती मिळत आहेत? अमोनिया 2 mole of अमोनिया मिळत आहे. मग बेटा 1 mole मधून किती मिळेल? येस, 2/3. मग त्याच्या ओरिजिनल मोल किती होतं? 5. बेटा 2/3 इंटू हाऊ मच? 5 into 10⁻³ mole. Yes, you will get answer how much? 0.66 into what? 5 into 10⁻³. So yes, your answer very good. 3.3 into 10⁻³ मोल. म्हणजे हे आपण आन्सर काय काढलं? मोल मध्ये काढलं. ठीक आहे बेटा, यू कॅन क्रॉस चेक युअर आन्सर. अंडरस्टूड? So you can cross check also your answer. Okay. So I am giving a few minutes to cross check your answer. Okay. So you will get like this what? 3.3 into 10⁻³ mole. हे काय आलं? म्हणजे how that much mole of ammonia gases form we got. आता जर का आपल्याला मास मध्ये काढायचं असेल तर मास मध्ये कसं काढणार बघा. ते mass of ammonia gaseous form. Mass of ammonia gaseous form is equal to how much? Yes, 3.3 into 10⁻³ into how much? एका मोलावर मास किती आहे? Yes, 17 into 17. Okay, so you will get answer near about 56.1 into 10⁻³ gram. Okay, it is upon 56.1 kg. Okay, so I hope you understood this thing clearly. So you can cross check beta your this answer. Okay. I hope you understood this thing clearly. This much gram you will get. Okay. So beta you have to write this your answer. Okay. So see here we will solve few another also numerical. So you concentrate on that numerical beta. Okay. So concentrate beta on that numerical. See beta what it is numerical actual. And whatever I am giving that now numerical, that you can solve by your own way. Okay, you have to solve in your notebook and share me the snap of that fully solved example. Okay, so whatever I am writing here, okay, so you have to solve it that numerical like this. Understood? So see here, the you can write this numerical, and you have to solve by your own, and whatever fully solved solution you have to share me personally. Okay, on my personal number. Your question: 56 kg of N2 gaseous and what beta? 10 kg of H2 gaseous are mixed to produce here to produce what beta? To produce ammonia gas. To produce ammonia gas. Then calculate, okay, then calculate the number of moles of ammonia gas formed. Okay, beta, this you have to calculate. Okay, so like that we have to do the calculation. Okay, so beta, you have to calculate this numerical and whatever answer you have to share. Okay, on personal number. So here we will discuss here one more numerical on the basis of our limiting reactant. So pay attention, beta, how we will discuss the another numerical on the basis of our limiting reactant. Okay, so you can write. So see here, beta, if what they gave in next question, if 20 gram, if 20 gram of CaCO3 is treated with 20 gram of HCl, of what beta? HCl, then how many grams of CO2 can be produced, CO2 can be produced according to the reaction, according to the reaction. So pay attention, beta. So see here, what they gave in the form of what they gave the reaction. So concentrate. See, CaCO3, they gave one reaction, CaCO3 plus 2HCl aqueous, that gives what? Yes, that gives CaCl2 aqueous plus H2 liquid plus what? Yes, CO2 gaseous. Okay. So beta, you have to write this. You have to write this equation. That is your what? Question. Okay. First you have to rewrite this question carefully. If 20 gram of what? Calcium carbonate is treated with, okay, treated with 20 gram of HCl. How many grams of CO2 can be produced according to the reaction? So here you must know what? See it down. Already they gave reaction. Okay. Now 20 gram of CaCO3 is treated with 20 gram of HCl. पहिल्यांदा आपल्याला कॅल्क्युलेट करायला लागेल की किती मोल्स आहेत. हे 1 मोल आहेत, हे 2 मोल आहेत. Okay. And how many grams of CO2 can be produced according to the reaction? How many grams of? Okay. पहिल्यांदा आपण काय करूया, मोल्स रेशियो लावूया. So see here, CO3 how much? Here 1 mole. HCl how much? 2 mole. आणि आपले CO2 किती आहेत? 1 mole. And one more, we have to cross check what? Whether our reaction is balanced or not. 1 Ca, carbon, yes, one carbon. O3, yes, O3. Two hydrogen. 2Cl, yes, here also 2Cl. Means our reaction is balanced. Okay. Now see here. Now after that, here you must know what they gave. Yes, 20 gram they gave. Here how much beta? 20 gram they gave. And still beta how much they gave? Still also they gave how much? 20 gram. Okay, both are 20 gram. Now see here, we have to calculate what? Mole. Okay, आपल्याला मोल लागतात आपल्याला जेव्हा लिमिटिंग रिएक्टंट आयडेंटिफाय करायचं असेल तर. So we have to calculate first number of moles means given mass divided by what? Molar mass. आता इथे आयटम्स नाही आहेत लाईक N2 आणि H2. इथे काय थोडी मॉलिक्युल आहेत मग त्या मॉलिक्युल साठी आपल्याला काय आहे मोलार मास. मग बेटा कॅल्शियम कार्बनचा मोलार मास किती? येस कॅल्शियम 4040 carbon 12 and this 48. So total how much? Yes 100. See here beta. We can calculate 100 by 20 by 100 given mass divided by molar mass. So we can draw here directly also. See already 20 gram given mass is there divided by what? Molar mass, that is 100. Now here what? HCl बोलते किती आहेत?